This video lecture is meant to explore the trends in the periodic table, which is a continued lecture from the lecture on the trends in atomic radius. This particular trend that we're going to study today has to do with reactivity of metals and reactivity of nonmetals. So this corresponds to the objective you see here. Describe and give reasons for trends among the elements in regards to reactivity for both metals and nonmetals. Periodicity, as we've discovered, is the topic that explores the trends within the periodic table. There are properties of the elements that we will analyze to see how they change both within a period, horizontally from left to right, as well as within a group vertically from the top to the bottom, just like we did before in our previous lecture. There were 4 properties that we're studying in this unit. The first 2 we have already explored a little bit, atomic mass and atomic radius. We're now going to take a closer look at metal reactivity and nonmetal reactivity. All right, what we have here are a couple of videos that are showing you reaction of magnesium in water, calcium in water, and aluminum in water. And these videos are arranged such that we can hopefully see that magnesium above calcium on the periodic table, we want to see which one's more reactive, magnesium or calcium. And we'll see whether or not reactivity increases as we go down a group or whether or not reactivity decreases as we go down a group. Magnesium compared to aluminum, they are in the same period, so we are going to see what happens with these metals in water as we go left to right within a group. All right, so if I'm going to move these up a little bit so we can see these. Okay, here's magnesium. Hopefully we can get calcium to start playing as well. And aluminum is also playing. So if you take a closer look at these, we can see that calcium is reacting vigorously with water. Magnesium, if you look carefully, there are some bubbles that form. Up close you can see the bubbles on the magnesium there. And so if we take a closer look at that, the magnesium versus the calcium seems to be reacting a bit more vigorously than the magnesium. If we then compare magnesium side by side with aluminum, we can see that there are definitely bubbles that get produced with magnesium in water, but with aluminum there does not seem to be any bubbles that form at all. So it seems that within a period left to right, the metals are more reactive on the left side of the periodic table. But if we consider a vertical column within the periodic table, it seems that the further down the column you go, the more reactive the metals become. All right, I'm going to show you a video clip that shows the reactivity of the alkali metals in a little more detail. So this is the lithium, sodium, potassium column that is all the way to the left. And without any further delay, here is that video clip.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal's surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our fifth alkali metal.
So you can see from that video that the alkali metals continue that trend that we saw with the alkaline earth metals, the magnesium and the calcium, that as you go down the group, the metals do become more and more reactive. Now let's consider the reaction of the halogens. We're moving over to the right side of the periodic table. So now we're looking at some nonmetals, and we're going to see what they do with iron wool, which is kind of like steel wool. It's just a fibrous form of the metal iron. And we're going to be taking a look at the halogens. This is the fluorines, the chlorines, the bromines, the iodides.
What you can do is heat up the iron wool and drop it while it...
Start that over again.
Reacting the halogens with iron wool is an excellent way of showing that the reactivity of group 7 decreases down the group. And what you can do is heat up the iron wool and drop it while it's hot into the gas jar of chlorine. And there you can see the iron wool's reacting with the chlorine. They're the brown fumes of the iron 3 chloride.
Fantastic, you can really see it reacting, can't you?
Yeah, and then you can see that the chlorine's disappeared, the green colour's gone out of the gas jar. Okay, this time what we're going to do is use some bromine to react with the iron wool. And we've put a few drops of bromine liquid, so I'm just going to warm up the bromine to get it to vaporise, and then heat the iron wool. And what we should see, once we can get the iron wool hot, is that it starts to react with the bromine vapour. At the moment all we've got coming out of the top is bromine fumes, and there you can see the glow and the reaction. All you're going to do this time is just warm the iodine up. It's a bit more difficult because it's a solid to start with. Just warm it up until you see the purple fumes, purple vapour. That's it. And let it go through the iron. That's it, just gently heating it.
And will the iron wool, are we expecting the iron wool to glow as well?
It'll glow, but it won't be as
Oh, you can see it happening now.
vigorous a reaction as with the bromine.
Alright, so we can see here in this video that the reactivity changed in a different way with the non-metals compared to the metals. So let's summarize this a bit. This is the metal reactivity. So we're going to focus on just the metals that we looked at. Magnesium versus calcium. Calcium was more reactive than magnesium. So we saw that there was an increasing trend of reactivity as you go down a group. But that aluminum was less reactive than magnesium. So the metals on the left side of the periodic table are more reactive than the metals on the right side of the periodic table. So it turns out that these metals down here are the most reactive, and the metals up here are the least reactive. Right, so we then saw with the non-metals, fluorine was the most reactive. Okay, so this is the most reactive nonmetal, and the most reactive metal here was fluorine. So again, it's this idea that the opposites, the extremes of reactivity, are on diagonally opposite parts of the periodic table. The most reactive metal is in the lower left corner, and the most reactive nonmetal is in the upper right corner. The noble gases, you notice we did not discuss those. All of the noble gases are essentially non-reactive. They have a full valence shell, and therefore they have no need to react with any other elements. So we just ignore them for this discussion of reactivity. All right, we're going to leave you with a video clip from, this is a Brainiac video clip, and I'll just let that take it.
School, you're still at school. You can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.
All right, so this concludes our video lecture on metal reactivity and non-metal reactivity. Thank you very much for listening.